Okay, it's time to get started on Lab Module 3. And as always, we're going to bring up Visual Studio Express and Internet Explorer, so let's do that. I'll launch Visual Studio first, put it in the background, and then bring up Internet Explorer. Once you get logged in, you'll notice that this time the layout of things is going to be a little different in Blackboard. You'll see that this is an alternative layout that I talked about before. Again, I'm going to go into PRG155A. So if we go in there, you'll see that the layout that's in Blackboard is sort of an arbitrary thing. Over here what we've got is we've got announcements, assignments, but no longer do I have in the assignments the actual lab modules. The lab modules are, strangely enough, under lab modules now. So let's click on lab modules, and as I said, you have to be aware of where things are, and you can check it out by just going around. Now notice also that I've changed this around to not just be PRG Lab 1, but to have the actual title. So this week we're going to be doing variables, data types, input and output. So let's click on that and bring it up. And there's the lab itself. And as before, what we're going to do is we're going to use the text selection tool to grab what's here. So what I'm going to do is I'm going to drop this down to, I don't know, about 65%. I think should work. And that just gets it in there, and make sure the text selection tool has been highlighted, not the hand. And if we do that, we should be able to use the left mouse button and select all of this text, Control C, as we've done before, and go back here. Now you can see we've got Lab 1 and Lab 2, and if you remember last time, what we did in Lab 2 is we have Lab 2A, 2B, 2C. We'll have something like that probably today. So we're going to say File, New, Project again, and we're going to bring up the standard stuff here. And as before, we've got Win32 console application. Down here again, we're using the F drive. So let's type in Lab3. And we're just going to say OK. And again, we're going to go and always do empty project and just say finish. So this should bring up what we had the last time. Now, what we're going to do here is under source files again, right mouse click, add new item, and we're going to add a CPP. So let's just add, and again we have to type the name, so we're going to call this Lab3A and say add. Now we still have all the stuff in the paste buffer. Before we put that in, let's go view. Let's go full screen as we talked about before. Let's get rid of this and Control V all of that information in. And it looks like I've set the font size a little big, so if you remember how to do that, we're going to go to Tools, we're going to go to Options, and let's bring the font size down just a little bit. Fonts and colors. And I think probably, I can't remember what I did send it at last time, but it's obviously a little too big for what we need for today, so I'm going to drop it down. 21. Let's drop it down to about 17. I think should work quite nicely. And again, what we have, part of our description is a little long here, so I'm just going to click here and bring it around and hit the delete button, bring this up here just to make it fit on the same screen. So the other thing that we talked about was syntax highlighting. Or the syntax color highlighting is a good feature to know that everything's right, but we also want to do indentation. So let's select all this and let's go from full screen back to here. Let's do the increase indent, and let's again go back to full screen mode. So when we're in full screen, let's see, again the quotes we're going to have to change. So let's go about doing that. And there's some other stuff that's going to have to change as well. Let's take a look up at the top here. This is called a programmer's block, and you're going to have a title for your programmer's block, get and print the name of this. So we're going to have title, author, date, and description. Now you can see this is January 2007, so that's definitely not today's date. But under your name, what you should put in is your name in this format. Your name, your student ID number, and also which lab section you're in, PRG155 in this case, A. And then you should change it to whatever the current date is, and Today's date, I believe, is June 4th, 2009. It's obviously going to be a later date for you once you watch this video. And that's pretty much all you're going to have to do to make these changes in here. So what you're going to find is you got your name, student ID number, and your lab section. Now there's some things that you're going to notice that are a little bit different. We have indeed our variable declarations, which we should have here. That's pretty normal. But we have something called system clear screen, and if you remember, system is kind of a neat command. It requires an include that we'll talk about again in a second. But CLS is a DOS command that clears the screen. Now, if you're on a Windows-based system, as we are, then system clear screen will work. If you're on a Linux system, chances are it won't. You can have to then know how to put in the Linux commands, but you can even say system quote dir quote, and it's going to do a directory listing of your files. So anything that you've got that's a DOS command, you can say system and put into quotes CLS. Now let's take a look up a little bit further here. And if you take a look, one of the things that you should do, and we're going to be doing this a little bit as we go through, is on the include section, we've got number sign include and standard io.h, and we should fill in what these are definitions for: scanf, printf, and we're using scanf and printf in this code. We also have include conio definitions. It shouldn't say for conio, it should say definitions for getch. So let's change that. So it should be for that. And the definitions for the system are from standard lib. So there was a bit of a typo there. Now all you have to do, and you can pause the video after a while when you get this done. The only thing is you're going to have to write your name here, so put your name there. And once that's done, make sure you change all the quotes as we've done before, and pause the video till you do that, and we'll start up again. Before we continue on too far, I wanted to just bring your attention to the scanf. Notice there's scanf and there's two percentage signs, and both are %f, and we've got two variables. So you can actually scan more than one variable at a time using this format. One of the things that you should never do is you should never put a comma or anything through like this, and a lot of people will do this. That is not allowed, so never ever put commas in. In fact, if you want to do this as minimally as you can, then actually putting in a scanf, whoops, let me get the cursor out of the way here, doing a scanf with actually no spaces in between the various formats is probably the best for you. Okay, let's run this up and see what happens. And again, that's F5, and it's going to do the build and stuff. And let's see what's going to happen here. There were build errors. Let's see what it says. And this is where it gets a little difficult to understand. So let's go down here and take a look and see what it says. Lab3b, blah, 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 blah. Error, missing type specifier integer assumed. Does not support default integer. I wonder what that's about. And it happens to do with this. One of the things that you're going to find is that some compilers are very good with main by itself. Other ones are going to be a little bit fussier about your declaration of the main function. So what we're going to have to do is we're going to have to go in here and type int main, and then in the brackets void. Now these things you may or may not understand these concepts at this point, integer main void, but later when we get more and more into functions, this is going to make perfect sense. Now once we've done that, let's hit F5 again, and everything seems to be going through perfectly this time, and it's linking and so on. So that was the problem. You have to define the function main to be properly done, integer main void. So when this thing finally comes up, and here it comes, it's going to generate our DOS screen again, and it says input two floating point numbers separated by spaces. I'm going to just type 3 and 4, and even though it's taking in integers, it's really going to scan them as floats. So we hit the enter key, and notice what we've got up here. It says here were two integers that we entered, and it's going to promote them to floats, and it's going to say the numbers are 3.00 because we typed 3, and 4.00, and the sum of the numbers is this. Hit any key to continue. And as before, what we can do is right mouse click, edit, mark, and grab the exact output of this, and then right mouse click over here, and let's get rid of our compiling window here, and go down here and enter /* enter control V //, and this will generate the output of our program in our program code itself. So we pretty much have the first program done. But what you should do is go through this and notice that there's some various sections in here. Variable declaration block, let's go up here and take a look. Let's drop this down just a little bit. Variable declaration block, explain the program to the users, get the number from the users, usually you do some calculations and stuff, and then you generate output. So that's basically what it's talking about in here in the various sections of code, and that's what we're going to be doing pretty much all semester. Now let's take a look and see what we have to do for the next part of the lab. Now you can see on here it says that we're going to begin all of our programs by clearing the screen, and that's going to involve using standard lib.h as an include, because we're going to be using the system CLS command. And it says save this as lab3. We've done that, and notice that we're going to get an instructor's initial here for completing that, so that was fairly simple to do. Now even though we've copied and pasted it, you should be able to, if you were given this as an exercise to do, you're going to learn a lot more by actually typing the keys and typing this in instead of copying and pasting. And that's going to teach you a lot more, because you're going to take a look, and these are the hard things to do, because actually taking a program and creating a program based on some words, which is like math word problems, which nobody used to like, is tough to do. So let's take a look at this second program that we have to write. And it says write a program that asks the user to enter his or her single letter initial and their age in years, months, days, all in integer. So I think you notice the single letter initial will be, yes, you got it, character. We've got days, months, years that are going to be an integer, and then it's going to do some calculations, and it's going to print out your total age in days based on a calculation as a float. And it says the output's going to look like this. Now, as we talked about before, there's going to be variable declarations. There's going to be after that explain to the user, and this will be part of the explain to the user here. This program was written by, and there's some other stuff that we'll put in as well for that. Then there's going to be get user input. There's our user input, and we'll be doing some calculations. We won't be showing those on the screen, but then we're going to be generating our output after our calculations are done, and this is our output. So those are the basic sections of code that we're going to do. Variable declarations, explain to user, get user input, do some calculations, generate output, and that's pretty much what we're going to be doing all semester. And it says to make this lab3b. So let's go back and let's start this up. And if you remember how we do this, let's go back from full screen back to here. And we've already saved that, but let's just make sure. Let's just go down here and say save lab3a.cpp, and let's just make sure it's saved. Once we've done that, I think you remember we have to right mouse click and remove this, and don't delete, just remove. And at this point then we can say right mouse click, add new item, and again just we can type in, this one is going to be lab3b. And if we do that, it's going to come up here with this empty template, and what we're going to have to do is actually create all of this from the get-go. Now you're saying to yourself, geez, that's a lot of typing, and you're right. So I'm going to do something that I should have done at the start of this. I wasn't really thinking. So let's remove this one and go back just for a second, and just to show you that you can do this, let's say add existing item, and let's go back and grab lab3a for a second. And what we can do, and this is kind of cool, let's go view, because we're lazy and you're going to learn these things anyway, so I might as well show you. So some of the things that we don't want to have to do is we don't want to have to type all of this in. Now obviously the programmer's block is going to be a little different, but the basic format is here. So I'm going to control C that, and then I'm just going to go back and from full screen back to here, and what we're going to do is we're going to remove this again. So sometimes you can actually create a new program with some of the stuff without having to type everything in, which is a godsend. So add new, oh, we did create it, didn't we? Let's try existing item. Is it there? Yeah, there it is, 3b. And let's go to the source portion here. let's go full screen. And at this point what we can do is just paste all that stuff in, Control V. Now obviously the programmer's block isn't quite right. This one is not going to get and print two numbers, but we can modify that. We've got the basic format here. So what it is it takes user's age in days, months, years, and converts to days, to total days. Now we don't really care if it goes around a little bit. Now we can wrap this around if we want, just to make it a little bit easier if it's a long title. And your name, student ID, and your lab section hasn't changed, the date hasn't changed. So let's write down in our description section what exactly this is doing. This program, and if you read through the thing, it says we'll first take your initial, then ask for the number of years, months, and days that you have been alive, period. Then it will calculate the total number of days you have been on this planet, if we want to put it into that kind of context. So we've almost written a book here, but we're going to be using the description as part of explain to user later, as well as this program was written by. Now let's go down here, and if you remember, we've got Scanf, printf, and so forth. And once we've got our basic programmer's block up here in our include section, we should actually highlight that and say 2 forward slashes include section, just to let people know what that is. And then we're down here to integer main bracket void, and our actual code will go in between two brace brackets. Now what do we have to put in here? Well, the very first thing we should do is actually say to ourselves, okay, let's put in a skeleton. And we're going to put in variable declarations, because that's the first thing we're going to have to do. And this is just a comment. After that, we're going to explain to user. After that, we're going to get user input. After that, we're going to do some calculations based on the get user input that we've got. And finally, we're going to generate output. So these are the four basic sections that we're going to have in all of our programs: variable declaration, explain to user, get user input, calculations, and output. And that's pretty much what we're going to be writing for the next little while. Well, let's take a look and see what we need for variables. And there's three basic types that you should have learned about so far in class: character, integer, and float. And we're going to be using actually all of those three today. So let's go back and take a look and see what it's saying. It's saying write a program that will ask the user to enter his or first initial, okay, and let's see what it says here. Write a single letter initial and his age and so on, so blah 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 blah. Now, as I said before, this is what makes programming a real challenge. You have to look at what it is you're being asked for, analyze it, and then put it into code. Now, write a program that's for a single letter initial. Now, things that are letters are going to be chars. So we're going to go back and let's take a look. So our first variable we're going to have to put in is char, and it's supposed to be containing your initial. So we're going to use the word initial, or the variable initial, as the character that we're going to grab from the keyboard is going to be put into this variable. Let's see what else we're going to need. And it says we need something for years, months, and days, all in integer. So let's go in and we're going to put integer, years, months, and days. And let's see what else we need. And as it says down here, it's going to say the total number of days. Now, the total number of days is going to be based on a calculation. Calculation, you can see, has decimal parts. So chances are our final total number of days coming out of all this should be in float. So let's go and create a float variable, float total underscore days. Now you should have learned by this point the naming convention for variables and other identifiers. You can start with a letter or an underscore, and after that letters, underscores, and digits 0 to 9. So that's pretty much our variable declaration. That's probably one of the toughest parts, is to figure out what kinds of variables we need and come up with names. Now these aren't very creative, but they do express what these things are. Now we're going to do something interesting here. We're going to put in whatever description. This is just a comment. It's not going to print out, and it's sort of reminding the programmer, which is you, what this program does. But we've written it in such a way, and it's kind of a nice thing to do, is to use copy and paste to put the same stuff coming up in the explain to user section. Now we're going to, as it says, we want to, and it told you this in the prior program, we want to start off by always clearing the screen. And you're going to see when you do your project, this is going to be a very important thing. And if you remember how to do that, it's just basically system CLS, and again you need the include standard lib.h, which we've got and we copied in from the other program. Now here's a new command, put string, and here's the beauty of a put string. Let me just show you how they're similar. Printf backslash something backslash n. Whoops. So if I did, some sdf df, if I did this, let's take a look. These two statements are equivalent. Put string sdf df is just some nonsense they put in a string, is exactly the same as saying printf, the same thing, with a backslash n at the end. What does this mean? A great way of printing text is, instead of using printf, it's just a little less typing. Actually, put string is a little shorter, printf than printf, and we don't have to automatically put in the backslash n because it's done for us in the printf. So here's what we're going to do. This is kind of neat. We're going to just put in some put strings. We're going to use put strings to print out text, and that's what they're good at doing, is printing out text. They can't print out variables like printfs can, but they can do this. Now what we're going to try and do, as I said before, is we've got 1, 2, 3, 4 lines, so we're going to have 4 put strings, plus I'll add an extra one to leave some spacing. So again, being the lazy people that we are, we're going to do this all semester. Let's just grab that put string. Notice that what I've got, this thing sitting here again, just if you haven't seen this before. I've selected that and then slid it down to the next line. And then I'm going to Control C, Control V, Control V, 3, 4, 5. So we've got 5 put strings in there without a lot of work. And what we're going to do is we're going to go up here and we're going to grab the very first line of text, Control C, and what we're going to do is pop right in between these two quotes and Control V. And we're going to go up and get the next line and do it for all 4 lines that we've got here. So Control C, just put it in here, Control V, and third line, and one more line after that, and we're pretty much done. And you can see that copying and pasting is great, isn't it? We've been able to copy and paste chunks of code. We can duplicate whatever you've got for explain to user right out of your description, and so forth. Now, you might want to test your code and just see if this is working, and this is a great idea to do. We've got variable declarations, we've got this, and when you start developing code, you want to make sure that you got it right as you're going. Now in the output section, the very last thing we always do in our output section is put in a get ch. Why are we using get ch? Because we're definitely going to be scanning stuff and getting user input. So get ch is a safer one, or you can f-flush as we saw before and then do standard in and then do get char. So let's just put in a get ch and let's punch up F5 and make sure everything's going to work so far. Whoops, we got unreferenced local variables, but it's still linking. In other words, we've declared these variables, but we haven't used them yet. That's what that means. So look what we've got. Let's see our code. It's just a bunch of explain to user stuff and then a get ch. So if we hit the enter key or any key, it does work. So everything is working so far, and we've checked out that that is indeed the case. Now, it did complain about these variables. We've declared them but haven't used them. That's not a critical error. Okay, so the next section that we're going to do is get user input. Obviously, your memory is about as good as mine because we forgot something, didn't we? Let's go back and take a look. The thing that we forgot to do is we have to also generate, as part of explain to user, who the program was written by. Now, if you're really proud about the work you do, we can just basically grab this, Control C, program was written by, and then let's go back and let's put in put string, quote, Control V, and some reason or other it kind of wrapped it around, but let's put it back here, your name, and put a quote, and we'll put in, change this to be your actual name. And one other thing, notice that we've got our cleared screen, 4 lines of description start right at the top, and you can see that this is like a \n, as we talked about. It prints this on that line, \n automatically. But what we'd like to do is now leave an extra line after this to say program is written, so that sort of separates you out from everything. But we also want to take this and leave an extra line after who you are. So let me just go back up here and Control V, so you can see Control V is a real nice thing. Now I can run this up, but I think you'll notice that these print strings or put strings will basically do, we've shown everything except these last 2 lines, so everything should work. Now next thing is to get user input, and it talks a little bit about that. Let's take a look back and see. It says please input your initial, and being the lazy guy that I am, I'm just going to grab that, and I'm going to Control C, and let's go back. So that's the prompt. So forget user input, we're going to have to do a prompt. Now we could possibly use a put string, but put string will put us on the next line. We want to keep the cursor on the same line, so we're going to do a printf. I'm going to do a Control V and a quote bracket semicolon. So that's going to be our scan, or the stuff that we need before the scan to tell the user what we're scanning. Then we're going to scanf, scanf, and the thing that we're scanning is a character. So we're going to do, if you've looked this up in the book, %C, and here's a little trick that's going to save you a lot of work, is let's first of all take a look at what we've got so far. Scanf, quote, %C, quote, comma, and then we put a variable. Now the thing that screws up a lot of people is that they forget to do is to put in an ampersand in front of the variable name. So let's take a look back here. So that's basically all we have to do now is put in the variable name. Now here's a little trick, because sometimes one thing that screws you up is if your variable names aren't exactly the same, then it's going to tag one with an error and say I don't understand what this is, even though it's very close. It has to be exact. Well, how do we make things exact? Well, we can go up here and just double click on the variable, Control C, Control V, paste it in. You're never going to have an issue with variables being mistyped again. So please input your initial, scanf a character. Now let's take a look at what else we have to do. Let's go back. Please input your years, months, days, all in one line. So these are going to be 3 integers. I think we can figure out how to do that. Let's go back. And we're a bit lazy, so what we're going to do is we're going to go down here and copy this. Control C, Control V, Control V. Please input, and we're going to again be even more lazy. Let's go back here and say please input and overcopy that message back here. So let's do that. Please do Control V, and again it's somehow for whatever reason wrapped that around, but we're okay. We're back to here. So please input your years, months, days. Now if you remember, we're going to have to change this. Now right now it's got 3 things, years, months, and days. So we're going to have to put in 3 variables, and they're definitely not going to be character, they're going to be integer. So here's how we do it. We just say %I, %I, and it's not initial this time. Now I'm going to do something a little bit silly. I'm going to do Control C, Control V, Control V, Control V, and I'll put commas in between these, and you'll see why in a second. Now what we want to do is we want to put in 3 variables, but our variables are years, months, and days. So here's what we're going to do. We're going to double click, Control C, years, double click here, Control V, double click on months, Control C, Control V, double click here, Control C, Control V, and now we've got our scans all set up. Please input your initial, please input your years, months, days, and everything goes very, very smoothly. Let's see, is there anything else we need? Let's just double check. Oh, the rest of this is going to be output, isn't it? So we've done variable declarations, We've explained to user with what our normal description in our programmer's block was, so we've added that, and we've added this line. That is all your explain to user. These two lines here are your get user input, and the rest is just going to be some calculations first and then our output. So let's look at the calculations part. So we're going to put the calculations stuff in here. Let's see what the calculation stuff is going to be. And it talks in here about the calculations. It's going to be 365.25 days for every year. So we're going to have to multiply 365.25 times the years that we put in up here as years. And then we're going to take each month and multiply that by 30.4. And where did they come up with this number? Well, 30.4, if you think about it, some months have 30 days, some have 31, and February has 28 every fourth year. That's why the quarter here, every fourth year it's got 29 days. So that's where these numbers come from, and then we just add in the number of days. And the variable we're going to use, let's go back. Variable we've got, let's see, for this is total days. So just double click, Control C, and here's our calculation. Aren't we lazy? Total days equals. Now again, what we want to do is not have to do a lot of typing. It's 365.25 times, and let's grab again, Control C, this is a great little programmer's trick, Control V, plus 30.4 times, again, months, Control C, let's paste that in there, and plus, I could write it in, but I'm lazy. And look, it even has a semicolon at the end. Don't forget when you're doing your variables, it's integer, whatever, comma, whatever, comma, whatever. The last one has to have a semicolon. Control C. Let's just put this in here. And we've got our calculation ready to go. And the last thing we have to do is just the output. As I mentioned before, one of the things that we'd like to do, though, is check our program each step of the way. So I'm just going to punch up F5 and see if everything is going to be okay. And it worries about some stuff of Scanf and whatever, and but it's still linking, which means we haven't got any critical errors. So let's put in our single letter initial. Let's put in our years, months, days. Now, what I'm going to do is put in 5000, and now I'm hitting enter, and everything seems to be working quite well. So everything seems to be good, and it says down here, and this is pretty cool, program has exited with a code of 0. Now we're going to see what that means later when we do a little bit more formal definition of main. But for now, everything seems good, which is a good thing, and everything seems to be running, but we haven't got any output. So let's see what we can do to generate our output. Excuse me. Now, notice it tells us what our output is. So what we're going to do, we're lazy, aren't we? Control C, and we're going to go back here. And what we're going to do is we're going to say printf, and let's leave a couple blank lines. Let's do quote, \n, \n, and let's do our Control V. And again, for whatever reason, it's trying to do some weird stuff. Now, notice that if we were to print all of this stuff out and then put in our variables, it's going to go off the screen. So what I'm going to do is another little programmer's trick. I'm going to put a quote here and break the line and say printf, quote, and continue the line on here. Now we can't really finish this off this way, because what we're going to have to do is we're going to have to put in the actual variable that we're going to print. And before we put in the variable that we're going to print, your so many years, we have to put in a print format specifier here. And what we're going to do is years is going to be an integer. So you're going to have, you can either put %i as the format, or you can specify, say, %3i, which means if you've got 2 digits for your year, and most people will have that unless they're like 9 years old or something like that. Anybody from 10 to 99 will have a space plus 2 digits in here for years. And the other thing, after the quote, we have to put in a comma and actually put in the variable years. Now this is separating things. Let's take a look at it a little closer. So what it's saying is printf \n, you are %3i, and 3i, since there's one format specifier, there should be just one variable. And what we've done is we've split this one printf onto 2 lines, but we don't put any \n on here, and that will make sure it continues on the same line. Now, similar to this, The underscore says is just a way of saying, well, we need a print format specifier. Again, let's just use %3i and %3i here. And we need quote here and a comma, and we need our three variables. And our three variables are, and we're lazy, well, actually two variables, months, Control C, Control V, we'll then have to put in the comma, and finally Control C, Control V, days, bracket, semicolon. So this is going to print out. If we look back, it should anyway, and you should be able to convince yourself of this, that it should print out this first line. Now we have to go to a new line and print this out. So let's Control C that. Let's go back here, and this should be on a new line, so we're going to say printf. In this case, we're going to do quote \n. Let's do the thing here where we do a Control V, or \n, or so many days in total. Now what we're going to do is this is going to be our final answer, and if you remember, our final answer, total days, is going to be a float. So we're going to put in %.2f. That means we're going to print out this floating point number to 2 decimal places. I'll do quote, comma, and, because I'm lazy, Control C and Control V here. Now if everything works right, we're pretty much done. So let's punch up F5, and it complains about a little bit of stuff. It warns us about things. May be unsafe. Okay, and here's our final output. So I'm going to put in initial, and this is what I'm going to get you to put in, whatever initial you like, but then I'm going to get you to put in 5000. And why is that? Because I just want to see that, you know, get an idea of how long 50 years is. 50 years is 18,262.5 days. Wow. So you can put in whatever numbers you like, but I just want to, you can put in 100 and see it's about 36,000 days, so it gives you a rough idea in days of where you're at. And again, if you want, you can put in your own stuff, and I'd suggest that. How old are you? How many months beyond that year that you are, and how many days left in that month on. Actually put it in and try it out for yourself, and just see how many days you've been alive on the planet. And as we've done before, edit, mark, grab all this stuff, because you spent a lot of work this time doing this, and hopefully you got a memory stick to save this stuff this time. And what we're going to do again is go down to the bottom and put in /*, paste all that stuff in, //, and if you've actually put in your own information, you'll have a permanent record, well, for now anyway, and you'll have to update it later, as to how many days you've been on this planet. I think we have one more program to go, so let's get at that shortly. To get set up for that program, we're going to have to go from full screen back here. We're going to, let's make sure we save this, because we've done a lot of work, so let's save that, Lab3B. Once we've done that, let's remove, oops, before we remove, let's go back. Did we learn something? I think so. Let's go back here and grab, and let's go full screen to do this. And this is a standard thing you should be doing, I think, each time, is if you've created a program, grab this stuff. Why bother typing if you don't have to? So Control C, and go from full screen back, and let's remove this one. Say remove, and source files, add new item, and we'll call this one Lab3C. It's going to come up with that. Let's view, go to full screen mode, and let's paste in that stuff. Now we've got our template to work with here, so let's go back, take a look what's going on here. This one is kind of a cool program. Now this one is going to be using print format specifiers and tabs and stuff. Write a program that asks the user to input a cost. Now the cost will be actually asked for up above here, and once you have that cost, everything grows from that. So there's only really one user input. So we'll put that in up here, and then once we've done that, then it's going to then generate all this output, but not until we put that thing up here. Now once we get our user input, we're going to have to do some calculations, and then we generate all of this output afterwards. Okay, and notice instructors initial. So each one of these, and if you look at it, I really should have mentioned this at the start. If we take a look, this means that you have to have, there's 3 instructors initials Each one is 1/3 of your marks, so if you get all 3 programs done, you get basically full marks, or 10 out of 10. If you only get 2, it's 6.5, and if you only get 1 working in the lab, that's 3.5 out of 10. So let's see if we can get everything working. So let's see what we need to do. So this is calculating total cost based on an input cost and PST and GST. So let's see if we can figure out what we want to write here. So program calculates total cost based on cost, comma, PST and GST. And let's just see if we can come up with a little better description here. This program will ask the user to input a cost, then it will calculate the PST, GST, and the total cost, and output them in a, let's call it fancy format. Okay, now again, let's take a look at what we have to do after this. We've got our include section, we've got our programmer's block or include section. We're going to have to do integer main bracket void, and let's put in 2 brace brackets, one open, one closed, and this will be where our program sits. And again, let's build a skeleton, and our skeleton is going to be variable, whoops, that's our very first thing. Very first thing is variable declarations. Second thing is explain to user. And next thing is get user input. Do some calculations and generate our output. And those are the, basically, I said before in the video 4, geez, I gotta learn how to count, 5 things. So if we read through that, let's take a look. Everything is pretty much float in this, so we're going to say float cost and GST. Now you can see that GST is 0.05 and PST equals 0.08, and finally we'll call it total underscore cost. So one of the things you're going to learn about variables is you can say float, which is the type, and cost is going to be a variable that contains initially garbage out of RAM. RAM is where these variables sit, and once you declare them, it's like a table that hasn't been bussed in a restaurant. It's full of crap. But this one here, GST, we've set up a variable location for it, but we've already put in with an assignment here as part of the variable declaration, put in the number 0.05 into GST. PST we put in 0.08 into that, and total cost has yet to be decided. And the reason for this is we know what GST and PST is, but the cost is going to be scanned, so we don't know what that is, so that's why it's called a variable. And over here, total cost is going to be based on cost plus cost times GST plus cost times PST to get the total cost. So that's what we're going to do there. Now again, what are we going to do for, and that was the hard part, variable declaration. For explain to user is very simple, system, clear screen. And how many put strings we need? Well, 1, 2, 3 plus an extra one, 4 altogether. So we're just going to put in put string as we did before. And we're going to slide down here, because we're lazy, Control C, Control V, 1, 2, 3, 4. Let's grab this information here. Control C, paste it right down in the middle here. Grab the next one. Control C, paste it in. And one more. So we've basically got that part of our code done. Explain to user. And the next section is get user input. Now we're going to do something fairly straightforward. Now we're typing more now. But let's say, please input your cost. And let's try it. Scanf %f quote comma ampersand, and let's just go up here because we're starting to get lazy again, and we've got our cost. So at this point we've got our explain to user or get user input, and the next part is calculations. Now if you've ever done this, and most people have to some degree, let's go for total cost here. Let's do our total cost calculation here. Control V. Total cost is going to be whatever the cost was plus the cost times the PST plus the cost times the GST. So that's what our total cost is. That's a pretty straightforward calculation. If you haven't seen it before, it's something you should learn because it's done everywhere. And let's take a look. This is where the hard part becomes, because everything else is pretty straightforward to here. The output is fancy though. Let's take a look at our fancy output. So this is in our output section. And being the lazy people that we are, Control C. And we'll go down here, printf, and let's leave a couple lines between what we typed in our scanf and what we've got here. And I'm just going to put, thank you for patronizing our store. And let's see what's on the next line. Oh, we have a bunch of stars. Let's grab our stars, Control C, and we'll say printf. And we better put an extra, we have to go to a new line because printfs aren't like put strings. You have to tell them to go to a new line. So there we go. There's our second line. Thank you for patronizing our store. Don't you love cutting and pasting? Anyway, now here's where it gets a little funny. We're just going to grab this much, and you'll see why in a second. Cost of purchase, printf, \n, Control V, cost of purchase. And what we're going to do is we're going to not use spaces. \t, \t dash, \t. We have to try some stuff out here. $sign. And then what we're going to do, because we want those $signs to line up, we're going to say %11.2f. And if you've never seen this before, what this means is we're printing out something in a field of 11 with 2 decimal places. And all the tabs are going to make sure the $signs line up, and the %11.2f format specifier is going to make sure that all of the decimal places will line up as well. So let's try that. Now to do that, we're going to put a get ch here at the bottom because we're doing scanfs here, get ch. So let's run it up and see what happens. See if this works. Whoops, I must have hit the wrong button there. Okay, let's hit F5. There we go. I just clicked on that ball. If that ever happens, you just click on it to get rid of it. Okay, it's linking, complaining as it normally does, but it's going to work. Input your cost. Now, I'm going to do something kind of interesting. I'm going to put it in 1E5. Let's go up and see, what the heck is this? Please input your cost. I got 1E5. That's 1 times 10 to the 5th. Well, 10 to the 6th is a million, so that's 100,000. Okay, so let's just try typing that in and see what happens. Whoa, it's a little bit too far along. So I've got too many tabs obviously in here, so I'm going to have to back this off a little bit. So let's readjust things so that it's all going to fit underneath these stars. So let's close that and play a bit. And this is what you're going to have to do with this program a little bit. So instead of 2 \t's, let's make 1 \t, and let's try just 1 \t here. Let's try that. And let's F5 and see if that looks a little better. And we're going to try 1E6 this time. Let's go for $1 million. Hey, why not? Lottery's coming up again every week. Who knows? Could be you. Why not? It's never been me. Okay, 1E6. Let's try $1 million. Son of a gun. Almost fits, doesn't it? So you can see that this is pretty close. Now what I'm going to do, I'm going to just add 3 more stars on here. Okay? And then everything is going to work even for $1 million, which isn't bad. So let's just add 3 stars. Let's bring this down, and let's just add 3 stars. That's a little easier to do because those are random, 2, 3. So everything seems to be working quite well. So that's the first thing we're going to do. Let's go back and see what the next line of stuff is going to be. And GST. Now GST, let's do that because we're going to not use any spaces here. We're going to use tabs to make sure everything lines up. So let's do that. printf. We're going to have to go to a new line, so it's \n, control V. Now to get a single percent, as we saw before, and this is tricky, you're going to have to make sure you put a double percent. Now here's where we're going to guess. I'm going to do \t, \t, \t. Let's try 3. Then let's put in a $sign and put 11.2f, quote, comma, and what we're going to have to do is put in the GST amount. Now the GST amount is GST times cost. Now let's run that up. Let's hit F5 and see if it's going to work. Compiling, truncating, blah 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 blah. Warning, warning, warning. And here we go. Come on, let's see what it's going to do. Is it going to work? Because we're just guessing with these \tabs. So let's do 1E5. And something happened here. We got 11.2F. So there's something wrong with our print format specification. But notice, isn't this interesting? The $signs line up. So we just have to fix this one little problem here. So let's go about and fix that and see what the heck happened here. Well, can you see what happened? Yeah, indeed. I forgot to put in the percentage sign here. Now, if you look back, and that'll work now. If we look back here, you'll notice that the only difference is PST, and everything else is exactly the same. So when you see something like that, you should start saying to yourself, copy and paste, Control-C, Control-V, Control-V. Just change this to a P here. Change this to a P here. Whoops, too much. And we're pretty much ready to go. Let's run that up. I always like just seeing, especially when it's fancy output like this, to see if it's going to work properly. Excuse me. And let's see. We're almost there. Linking, embedding. There we go. Let's try it. Let's go for $1 million. 1E6. And look at that. Everything is lining up beautifully. Look at how that is just so cool. Wow. Pay $1 million and how much are you spending? 5%. That's just sick, isn't it? Okay, so we're almost there. We've got this working. Let's take a look, and we want to leave a blank line and then say total cost. And then another blank line and then please visit. So let's try that. Blank line. Let's get rid of this. So simple thing for blank line is put string and total cost. So we say printf, again backslash. Well, I guess we don't need a backslash n, do we? So we've got a couple ways to do it. We can actually say put string, quote, or better still, because we have to print out stuff. And if you're printing out variables, you can't use print or put string. So let's do backslash n, backslash n. That's probably a better way of doing it. And say cost. And how many backslash or total cost, isn't it? Well, we're lazy. Let's go back and get the actual word exactly. There we go. Control C. And let's go Control V, Control, and then how many backslash tabs? Let's try 3. Backslash, whoops. Backslash tab, backslash tab, backslash tab. $sign this time. Let's, whoops. $sign. Let's remember put a percent 11.2f, quote, comma. And being lazy, let's go up here, Control C, Control V, bracket, semicolon. Let's see if that's going to work, and then if it does, we're just cut, whoops. Gotta watch just if that red ball comes up because I hit something other than just F5. And you'll do that too. So just click on the ball, it goes away. Okay. Let's see here. We're almost there, almost there. Let's try this again. 1E6. Look at that. Total cost. Everything's coming up so beautifully. So the only thing left to do is just finish this off. There's just a little bit extra formatting and we're practically home free. So we leave an extra blank line. Please visit us again. Yeah, if you're going to spend $1 million, come back anytime. And let's put that in. Printf, whoops, printf, backslash n, Control V, come on down. And what's the last thing to do? Oh, just that line. Well, we've already got that line, don't we? We already have the line up here, so why type it in again if we can just do this? Let's grab that. Control C. Oh, fine. I hate when it does that. There we go. Control B. And that should be it. Let's give it a shot. Now, if this program runs as it should, you should be able to use with 11.2f, you should be able to use it to sell $1,000,000 houses, but you should be able to use the same program in a dollar store. So when you show this to instructor 1E6, it should show up really nice like this. Thank you for patronizing our store. Yeah, I'll spend $1,000,000. And if we run it up again and you type $1, it should still work for $1 if you're in a dollar store. And that's the end of this video. See you next time. Well, it would have been the end of the video except for a couple of things we forgot to do. Number one, this is not 5%, and you didn't stop me. Okay, well, we're in such a hurry to get through. And the other thing is we didn't copy and paste this fancy output back into our code. So let's finish off those last two little things. Let's go back and make this an 8% as it should be. Let's run it up, and what the heck, let's run it up for $1,000,000. Yes! And, well, hey, you spent all this work. Your time's worth money, so what the heck. So sorry about that. Hopefully this will be the end of this video. Let's give it a shot. Let's do 1E6. Oh, isn't that beautiful? Okay, right mouse click, edit, mark, grab all of that beautiful work. Right mouse click, enter. Let's clean up and do this last little bit. Make sure everything's perfect, because if I'm marking it, I want to make sure everything's perfect, and we're pretty much ready to go. So there we go, and this finally is the end of the video. Hope you had fun. Have a great day.